Well, hope my people in physical science are doing okay today, and make sure that you are staying on top of stuff. For people in my A cohort, you should have finished up the bubblegum lab and shipped that off to me. And people in the B cohort and distance, you had your own work to take care of. Make sure that gets into me. I'm a little concerned that people aren't quite getting the work in that needs to. If I'm making mistakes on my end, please let me know in terms of grading, but my sympathy for late work is going to be kind of limited because I'm giving you ample time to complete it, especially on these Wednesdays. You're going to have time, and what you're going to realize is that your time is going to be kind of crunched since we're trying to fit a semester into a quarter in terms of this block schedule. So don't get behind the eight ball on this quarter. Make sure you stay on top of things and use your time wisely. And I'm not seeing a lot of that online, so make sure you stay on top of it. So today we're going to start kind of what really most of this semester is about, and that's going to be physics. And specifically, we are going to talk about motion. Okay, and I would ask that you have your notes out. If you need to pause the video at this point and get them out, please do so. But we're going to start talking about motion because everything else in this chapter kind of starts with this whole idea of motion. So let's drag this puppy down and let's introduce a couple of terms here. And hopefully you have your notebook out by now because you've paused the video. If not, pause it, get it out, have your notes ready. And a couple terms we're going to look at. First of these is these two terms, displacement versus distance. Now, oftentimes in your life you may have used the word distance. We're going to bring up a new term today called displacement, and they are not the same thing. They kind of can be the same thing at times, but oftentimes not, as we're going to see. So let's define these terms. So let's say that I kind of take a wandering path here, okay? And I head in this fashion that you see here, okay? So the distance is going to be this total path that I am covering here. So in this case, this total path follows this line along here, okay? That is going to be my distance. Whereas my displacement is the difference between my final point and my beginning point. So this is my displacement. This whole thing is my distance. You'll notice here that the distance is significantly longer than my displacement in this case. Okay, so displacement and distance are not the same. Distance is like if you take a road to school, okay, that is going to be a distance. But if you were to go as the crow flies, that would be my displacement. So to drive this home in another way, let's say I swim a lap in a pool. Okay, I've got a swim meet and I take this pool and I swim one direction across here and then I swim back. Okay, my distance there would be 50 meters. That's how far I swam. My displacement compares me from where I ended up to where I started. If I started here and I ended here, my displacement is actually 0. So that's the difference between those two ideas. And also, we're going to find out that displacement is going to end up having a direction. So if I look here, my displacement might be 5 miles east, okay, in this case. Whereas I can't really point out a direction for my distance because here I'm heading south, here I'm heading east, here I'm heading north, okay? But my displacement has a definite direction. So let's build upon that a little bit. If I have distance and displacement down, now I can compare a couple other terms. And if I ever start going too fast, guys, just pause me, stop me, and write notes on what you need to do and rewind, okay? So here, speed, which oftentimes we'll talk about, is distance divided by time. Velocity is displacement divided by time. And I want you to pay attention to these two, okay? So there's going to be a little bit of a difference there. We are usually going to be using this term in this class, velocity. And there are a couple reasons for that. As I suggested, since displacement includes a direction, velocity is also going to include a direction. So I might walk 2 meters per second to the north, or I might throw a ball 10 meters per second upwards. or I might be falling at 5 miles an hour down. Okay, so those are different velocities. They are going to include direction, unlike distance. Distance is not going to include direction. So if we were to look at this again, we consider this. Notice what would be greater here, my distance or my speed or my velocity in terms of magnitude. In this case, I traveled a greater distance than my displacement, so my speed here would be higher than my velocity, okay, because speed is distance divided by time, and velocity is displacement divided by time, okay. Let's get this down here, and let's see. So let's kind of keep moseying down the line. That brings us to a new idea, and that is acceleration. Acceleration is a change in velocity over time. Velocity doesn't have to be constant. I can displace myself a greater amount in a certain amount of time or a lesser amount, okay? And acceleration also includes direction, just like velocity. And for instance, if I have a falling object, it will accelerate towards the ground. So it can have a negative value. Acceleration can be a negative value. For instance, gravity will accelerate objects at about a negative 10 meters per second, or negative 10 meters per second squared, roughly. What I'm going to have you guys do today is work specifically on graphing, okay? And we're going to try to graph some motion today. Let me pull this down here. And let's say I had a graph where I was trying to graph displacement. I'm going to write displacement over here. That's going to be displacement versus time. And I'm going to graph 3 situations here, and I want you to kind of think about what they mean. So if I have a line that looks like this, that means that there's no displacement. If there's no displacement, there's going to be no velocity. So let's use a blue line here indicating that. This means that there's no velocity because I'm not displacing myself at all. That's what that line would mean. But let's say, on the other hand, that I have something that looks like this. Okay? If that's the case, my displacement is changing over time. And if that's the case, that red one would indicate that I've got a positive velocity. But I don't necessarily have to have a positive velocity. I could have a negative velocity, and a negative velocity might look like this. Okay, so this right here would represent, let's use a pink line here, this would represent a negative velocity. Now, if I've got a steeper slope, let's say I've got this line, or a shallower slope, this line right here has a higher velocity. Whoops, let's use a green pen here. Has a higher velocity than this line because it's a steeper slope. Velocity is going to be displacement divided by time. And you'll see here that that right here is the slope of my graph is displacement divided by time. That's my rise divided by my run. So the steeper the slope, the higher my velocity is going to be. Okay? But velocity does not have to be constant. Let's again write down displacement over here and time over here. What if my graph does this? Now my velocity is changing, and I can tell my velocity is changing because my slope is changing. My slope keeps getting steeper and steeper and steeper. This would indicate that this object is accelerating because my velocity is changing over time. This ends up being a positive velocity. That's a positive acceleration. Each time I go, each second, I go a little bit greater distance or a little bit greater displacement. Now I could slow down. If I slow down, that might look like this, okay? Where now my slope keeps getting shallower and shallower and shallower. So here it's a steep slope, here it's a little bit shallower, here it's a little bit shallower. This yellow line would indicate that I am going to be, let's use blue for this. This would indicate that I am slowing down. That's a negative acceleration. There I'm slowing down. So those first two graphs were what we'd call displacement versus time graphs. But I could graph velocity versus time. So I'm going to put velocity on this axis and time on this axis. And I'm going to draw some more lines here. So if I've got a line that looks like this, that is going to indicate a constant velocity. There's no acceleration. Okay, I'm still going places. Let's say this is 10 meters per second. Okay, I'm still going places, but I'm not speeding up or slowing down. If, however, I have a line that looks like this, now my velocity is increasing over time. This would indicate a positive acceleration. But again, I have some things that don't always positively accelerate. I could have, whoops, kind of an iffy line there. I could have a negative acceleration as well. Acceleration. So, what I would like you to do is, based upon this knowledge, I want you to, there's a website that I want you to try, and basically all you're going to try to do is match the graphs with the description, and I want you guys to see how you do. It's mostly experiential. Just kind of finish it up. Do that, but more importantly, once you finish that, if you have any missing work, make sure you get it into me, because I'm going to start putting the assignments we've done so far kind of in the dustbin. They're in the past, and we're going to start moving forward, and I'm not going to go back and look and grade those. Okay, so make sure if you've got any missing work, you get that in. Other than that, I hope you have a nice Wednesday today. You had a beautiful sunrise. Maybe you can catch a beautiful sunset tonight. And that's unfortunately due to all the forest fires out west, but it sure gives us some pretty sunrises and sunsets. Okay? So don't spend all day inside. Make sure you get out and enjoy the weather, but also make sure you get your work done first. Hope you guys have a good day today, and we will see the B cohort tomorrow. A cohort, you'll have a distance lesson. B cohort, you're going to be chewing some bubble gum tomorrow. Hope you like it.